Okay. Assalamu alaikum and good afternoon to everyone. I, Saad Junaid, along with my co-hosts Fatma Shafiq, Abdul Ahad Hussain, and Shamir Khan, welcome you on behalf of NASAWorks to our second webinar of the series, Innovation in Aviation. Today we are joined by a very special guest who you might have seen on television in one of her numerous interviews, Dr. Sarah Qureishi.
Dr. Sarah Qureishi is the CEO and co-founder of Aero Engine Craft Ltd, Pakistan's first commercial engine and aircraft research and development company. She was the first female alumni of NUS EME College and went on to pursue her PhD in aerospace engineering from Cranfield University in the UK. During her PhD research, she assisted in inventing and patenting the world's first contrail-free aircraft engine, which formed the basis of her launching her company with the technology's inventor and the company's co-founder, Mr. Masood Latif Qureshi. So, Dr. Sarah, that is our intro for you, but why don't you walk us through your tremendous achievements and the work you've been doing and how it's impacting the country?
Okay, Assalamu alaikum. Thank you very much for your introduction. My journey, obviously, as you mentioned, starts with NAST. As I was in EME college and I did my mechanical engineering, I was the only girl. That was the first batch of women in EME college, and I was the only girl, female student in a class of 60 boys. Later on, I worked and did some internships and had some learning experiences at various industries in Islamabad and Lahore. Among them was Rastgar Engineering in their CNC division, and then the Honda motorbike and car plant. I learned flying at the Lahore Flying Club and received a private pilot license. After that, I went to Cranfield University in UK, where I did my master's in aerospace dynamics and controls. It was a research-oriented master's, and my research was on air-to-air refueling of drones, so that drones could have a longer flight because they are small planes and they have small limited fuel capacity. Meanwhile, I also started learning acrobatic flying, which is like, all these upside down maneuvers that you see in air shows, which is generally performed by the military. And then after that, I pursued my PhD in aerospace propulsion, which is primarily jet engines. So at that time, there was this, initiative by researchers and the industry that we need to make all engines environment friendly. They had reached like a pinnacle of technology in terms of engine performance. You could achieve like 1800 Kelvin temperatures in a combustor like a turbine entry temperature, and the single crystal technology for blades and directionally solidified blades. So then the trend was now not to focus on engine performance, but to redefine design, which is aligned with our environmental objectives. So there were targets were set like, we have to cut CO2 by 50%, we have to cut NOx by 80%. So there are different areas, different dimensions of the environmental impact of aviation and of aircraft emissions in the air. So there was a lot of research, and one of these areas is contrails. Contrails is basically the white smoke that you see out of an aircraft engine. And that is actually frozen water vapor because, when hydrocarbon fuel burns, you get water vapor and carbon dioxide. So because when you're cruising around 10,000 meters, the atmosphere is so cold and the temperature is very low. You are at 216 Kelvin and quarter bar pressure. So that water vapor freezes into an artificial cloud. And it also, it is in a molecular gaseous form, so it acts as a greenhouse gas. And as a contrail as well, it's like an artificial cloud that is covering the Earth's surface that traps infrared heat inside. Does not let infrared radiations escape the Earth's atmosphere, and it also blocks sunlight. So basically, what we call the greenhouse effect, which is more associated with carbon dioxide, but it is equally relevant to contrails as well. So the global warming impact is almost 5 times more for contrails in the atmosphere than for carbon dioxide. So there was a lot of research done on contrails, how to mitigate them, how to suppress them, how to avoid them, how to eliminate them. And this work had actually started after World War II because they could detect enemy planes because of the smoke that comes out of an aircraft. So people started adding chemicals to your exhaust so that, they would make the temperature higher so that the contrail would disperse or the particle size smaller. I mean, there were different techniques, but then again, that is not an environmentally aligned method to suppress contrails. But at least there was research on their impact and the research on the various factors that contribute to the formation of contrails. And then, once you understand those factors, then it is easier to design something that would prevent the formation of contrails. So I was given this as a research question. There was a lot of prior research on it. People were using different methods, but they were all very research oriented, but they were not very product oriented. And then I also started working on it, and I did part of my research in the UK. And then because meanwhile I had a baby daughter, so I had to move back to Pakistan um, for support. And here I did some of my research with my father. He's a very experienced scientist, one of the top 4 or 5 scientists of Pakistan, a retired scientist. So he got involved with my research, and initially the purpose was just to help me out because my supervisor was in the UK. But then he invented a turbo machinery which is attached to the engine between the core nozzle and the low power turbine that processes the exhaust emissions and converts the water vapor content into liquid water, stores it on board, and then when you are lower down in the atmosphere, you can release it as water or as rainfall. So this, because a lot of people ask me why can't these contrails recycle? These are clouds. Why don't they fall as rainfall? But if you look at the weather cycle, all your weather is the weather cycle operates below 2,000 meters, and contrails are formed during cruise flight at 10,000 meters because that's where your plane flies most of the time during a commercial cruise flight. It's like it's ascending for one, climbing for half an hour, descending for half an hour, but the remaining 7, 8, 10 hours are at 10,000 meters. So there's no way that those contrails, they just form a blanket like an artificial cloud that stays there forever. So anyways, moving on, we patented this invention. The university highlighted and my supervisor highlighted that this has a lot of commercial promise. It could be converted into a product that can be sold, and it has a lot of societal impact, global impact. So we decided that we would patent the invention first. So my father filed for 2 patents that they were granted internationally. They were granted within 15 months. And then I completed my PhD and all the validation on the design. And then we decided that we would, instead of taking the academic route to further research, we would take the commercialization route. We would develop the prototype and the product and, sell it in the market. So I came back to Pakistan and we set up this company in 2018, July 2018. And this was essentially Pakistan's first commercial R&D company in the aerospace domain and the engine domain, because earlier on, all aerospace R&D is restricted to the defense domain or airline operations. Basically, there's no civil aerospace in Pakistan, unfortunately. So we launched this company, and meanwhile, I'm still continuing as a visiting academic at Cranfield University, where a lot of students they do future work on my research as MSc projects on different dimensions of that work, and I assist them with their evaluation or thesis or whatever support that is required out of my expertise. And other than that, I also there's a Solar Impulse. If you've heard of World Alliance for Efficient Solutions or the Solar Impulse Foundation, they are at right now evaluating 1,000 green solutions for the world. So I'm an evaluator there. I evaluate different green technologies, sustainable technologies for the future that are applicable to the world. They come from all over the world. Different companies apply for their, label for their technologies. There are very few in the aerospace domain, unfortunately, but a lot in the other domains. And in addition, I try my best to spare time for students on such forums and to, guide them out of my experience uh, on their career planning and, the way they want to take their professional career ahead, especially if they want to go into aerospace. Other than that, sometimes I also go to schools to give some aviation lessons to young children, teenage children, so that, it's important to introduce them to this world of this exciting world of aviation, because they when they're selecting a career, if it's something that fascinates them, then they should know that this world also exists. And then lastly, I also lobby, or not exactly lobby, but I do like to speak on the topic of sustainable aviation and environment friendly in aviation. And the reason I feel that it is important to talk about it is, number one, it's a very specialized field. It's very industry specific. Aviation industry is the only polluting industry in the atmosphere, in the sky. Rest of all the industries are on the ground. Secondly, because it's very specialized knowledge, only people from the industry can let the rest of the world know about it. If we need to do something about that. And then it is very critical because you don't have any offsets. You cannot grow trees in the atmosphere. It's not visible. People don't see it. So when you don't see it, it is, it's a field that is neglected or ignored because, that's how, environmental work is prioritized. And then it's something which is common to all of us. I mean, we are all under one sky. So it's not that this is a Western world's problem or not our problem. It's everybody's problem, and it has to be dealt with. Gee, I think that's a fairly long introduction.
Can you hear me?
Gee, I can hear you.
Yes. So first of all,
I can't hear you now.
Shamil, you're muted.
जी बोलें.
Yes. So, yes, Dr. Sarah, first of all, that's an impressive list of your contribution to the aviation. And now, the real question right now is that how economically it is possible to introduce the contrailless engines globally, in a global perspective.
Okay. Okay, let me answer. You know that it depends how you look at things. Like if I tell you that we have COVID and how economical is the vaccine, or how economic is a ventilator, or how economic are the medicines, what would you say? You know,
I
so
would,
it's a category, it's a
yes,
necessity, right? So
yes.
it depends what your design parameter is, what your design rubric is, what your so when you talk about, because as engineers, especially as aerospace engineers, we are always trained to think that we have to optimize fuel consumption because fuel is expensive, right? And we have to optimize profits for airlines and reduce manufacturing costs. But then when you talk about, when we, if we talk about saving the planet, then it is a necessity. Then it is not relevant whether this would add a penalty. And I always quote the example of the automotive industry, because in the automotive industry, they have a lot of equipment um, integrated with your car, which is not contributing to the performance, and it's an additional cost to the consumer as well as to the OEM, to the manufacturer. But the industry is paying for it because they have to comply to environmental regulations like compliance and whatever. And so they have these exhaust gas recirculators, exhaust purifiers, the catalytic converters, so that there is, the pollution on the roads could be controlled. So this is a similar model. And in industrial terms, it's not very expensive. Number one, it's an add-on attachment. It's a turbo machinery. It's like similar to a compressor or a turbine. So it's very synergistic with the existing aircraft engine gas turbine technology. So the manufacturer who are already manufacturing combustors and turbines and components, engine components, can easily integrate it in their framework. So it would not be an additional cost to the setup, or to, it's just like having an additional turbine or having an additional compressor on your system. So it's not very costly. It would have an incremental cost to the engine itself.
Okay.
And then there would be a bit of a fuel penalty for the storage of the water, or for the performance of the engine or the aircraft is affected. You have a bit of an additional weight. But again, when you look at, if when you're design, because engineering design is always a compromise and it's a trade-off, and these trade-offs to the weight or the penalty of two is like, we are willingly accepting that, or they should be willingly accepted for the environmental benefit, because this can give you an overall reduction in global warming by 40%. So these trade-offs can be accepted.
Okay. So, Assalamu alaikum, ma'am. It was quite interesting. It was quite interesting listening to that. But like we have been hearing a lot about environmental technologies, like you can say environmental technologies like aircraft engine designs and like superconductivity, electric planes, hybrid planes, distributed propulsions, etc. So we would like you to give a short overview about it.
Okay. Uh, I had also made a small article on this. I hope I remember, but basically ये है कि one thing is electric planes, right? So electric planes जो हैं वो basically अभी तक our battery technology is not advanced enough that it can also and can only apply to regional flying or to short haul planes, because if you want to fly for 8 hours, then you need the battery, which is the size of the aircraft itself. So what they are doing is for short haul flying, they can make electric planes. Drones can be electric. Small executive jets or single seaters, they can be electric, right? Okay. Then we talk about hybrid propulsion. Hybrid propulsion, what they're doing in long haul flights is that they are using a combination of, it is also called hybrid propulsion or distributed propulsion. So that is basically a combination of this electric technology and the gas turbine. What they're doing is that they have one big engine which is driving a set of generators that is generating electricity to drive many small propellers. So this is the way they are going forward with the electric technology in the long haul flights or the large aircraft which are doing 8 hour flights, right? So the small ones can be all electric, but the long haul flights can be, could be hybrid electric, or you can also call it distributed propulsion. Okay, and then the third thing is superconductivity. Again, superconductivity has not made a breakthrough as yet. I have been hearing about superconductivity, I think, ever since I was a student and of mechanical engineering, and I heard that, once that breakthrough is made, everything would be redesigned. But we haven't achieved that level where we can redesign um, the bigger planes. But there's a lot of research on it, and some of the research is also classified. We don't know, maybe one day one company announces that we have, achieved this. Secondly, what they're doing, the third thing that is very common is hydrogen uh, propelled technologies for aviation. Now, there even in that there are two descriptions. One is hydrogen fuel cells, which are generating electricity. Just like you have batteries, you have fuel cells based on hydrogen, and they are again applicable to smaller planes, to short haul flights, right? And then you have liquid hydrogen combustion, because when you burn hydrogen, you eliminate carbon dioxide completely, but contrails are not eliminated. So this is a zero carbon technology. So there is a trend that Airbus has also announced that it would bring all its fleet to short haul fleet to hydrogen by 2035 and long haul fleet to hydrogen by 2050. But again, for long haul, they are just burning liquid hydrogen. And in that, they are also trying to make it synergistic with superconductivity, because you have, in order to um, burn hydrogen, for liquid hydrogen, you have to, cool it down to 20 Kelvin. That is called cryogenic cooling. So with cryogenic cooling, because you get very low temperatures, and superconductivity is also a phenomena of very low temperatures. So they're trying to combine these two technologies together, that they can, integrate them and synergize them and use them together. And then we also have one company, Reaction Engines, announced that it would use ammonia as a fuel for aircraft. Now, again, when you burn ammonia, it goes through a standard Haber process that creates hydrogen, basically hydrogen and nitrogen, and then they burn that hydrogen. So again, that is burning hydrogen, but then they are trying to bypass the element of cryogenic cooling, because the cooling hydrogen to 20 Kelvin on such a large industrial scale is not very easy. So they are trying that they achieve this by ammonia combustion. So these are different trends. Some of them, as I said, are only applicable to small aircraft, short haul flights like all electric and hydrogen fuel cells. And then some technologies are applicable to both short haul and long haul liquid hydrogen, um, and yeah, basically, or distributed propulsion. So these are the incoming trends when you talk about environmental technologies and aviation.
Okay. So now, Dr. Sarah, going up to the most interesting and the most important part of our webinar. Although you have already given us just about the contrail engines, but could you please elaborate more over the contrail engines, your own invention?
In what sense? I think because I've spoken on it on various forums. There's a lot of data available on it on the net as well and on my YouTube channel. But if there's any particular aspect that you want to talk about.
Just an overview over that, so that everyone in our audience always wanted to know about your more about your invention. Well, it's obvious in
Uh,
every forum you go, everyone wants you to tell us about your invention in any way you can.
Gee, well, I think I've explained enough. We all understand what contrails are. I've told you it's a turbo machinery. Um, it's integrated within the engine, and so far what we've done is that initially during my research, I did the basically the mathematical modeling and the proof of concept, then the development of the engineering design based on simulations, FEM, structural simulation of the machinery itself, and then we have the aircraft performance simulation, aircraft engine performance simulation. And then after that, we in the company, we started prototyping it. So for prototyping initially, we wanted that maybe we get hold of one engine and we just prototype our device and attach it to the engine and test it. But then we realized that it's very hard to get hold of an engine in Pakistan. So we developed our own engine. Again, that is the first jet engine developed and successfully run in Pakistan. So it's like a 1 kilonewton baseline thrust engine that we developed and successfully fired, alhamdulillah. And then we developed the prototype on a small scale, because for any new technology or invention, you first develop it, you prototype it in a scale down version, then you test it, you eliminate the design faults and errors, and you improvise it. And once it's uh, fully functioning, that's when you basically develop the actual real scale model. So at present, we have developed the engine. We fired the jet engine. We've developed the turbo machinery for the contrail free device. We've integrated it with the engine and we've tested it. It has had 2 test runs so far, and it is still under testing and improvisation, because with every experimental test, you just discover some design fault or some improvement or some modification that is needed. So at present, we are testing that, and we are targeting that it should be done by mid of this year. And obviously, like everybody else, we have been thrown back by COVID too. And then once that is the design is frozen on a scale down version, then we would build an actual scale model that would be integrated maybe to a CFM56 engine, A320 baseline specifications. Earlier, my PhD design was on A380 Trent 900 engine because that was the most popular aircraft and engine at that time. And also because, it is easier to scale down than to scale up. So that was the largest engine at that time. So if you could validate a technology for the largest scale, then you can be in a way sure that it would work for scale down versions as well. But now we see that a lot of A380s have been scrapped, and the most popular aircraft and the popular aircraft size is the A320 or A320 Neo, which has derivatives of the CFM56 engines like Leap A, Leap A1, and Leap B. So we would be using that as a baseline spec to develop the model for the real testing. And then meanwhile, an auxiliary system would also be used, developed for the storage of water on the aircraft and in the wing or under the fuselage, or whatever attachments that need to be made within the aircraft. So that is the plan that we are going by. And if you've heard of NASA's technology readiness levels that define like from 1 to 9, like from a concept to a simulation to prototypes to an actual airborne model to a commercial launch. So it's like from level 1 to level 9. So we are around level 5, approaching 6 now.
Okay. So, as Nurse our prime interest is UAVs. So, could you tell us that is there a scope of UAVs as environmentally friendly aviation technology?
Okay, I haven't given it much thought because then if you want to determine the environment friendly capacity, you have to go through an entire product life cycle analysis. There has to be an assessment that it's not because one environment evaluation is what we call thrust to tank to thrust rather, that this is the fuel, this is the thrust it's producing, this is the emissions it's giving out, and this is the environmental impact. But then the product life cycle assessment tells you that the manufacture of that product, and then the way it is, how environment friendly is the manufacture of the product, and then the operation of the product and the fuel burn and whatever, right? Because if you are just a very simple example, like if you talk about electric vehicles on the roads for Pakistan, um, so if you just go by the analysis, like a tank to thrust analysis, you would say, oh, it's zero emission, it's a wonderful technology, right? But then when battery technology is not very advanced, and you need to batteries are not magic, they need to be charged. You are charging them on electricity. So what is the efficiency of charging, and where is that electricity coming from? If it is coming from a power plant, if it's that electricity is green electricity from a hydropower or a solar power, maybe that's okay, that's green enough. But if it's coming from a power plant which is giving out emissions, then you are only transporting or shifting the source of the pollution. You're not eliminating pollution. Then that pollution is not on the roads, but that fuel is being burned in a power plant in Kota, Du, or wherever. So the pollution is just shifting. So this is very critical. In Pakistan, if you're talking with reference to Pakistan, I feel that we don't go into this product life cycle assessment. We think that one technology, or it's amazing to have electric vehicles, fine, but you have to go through the entire life cycle to determine that is it what is actually the environmental impact. If you talk about drones, Drones, yes, because they are small airplanes, they can go into the electric. They have more potential with the electric, all electric plane technology. That's one thing, which again is a zero emission technology. But as I mentioned, this issue about the product life cycle that has to be considered. And then in Pakistan, people are now working on a drone policy. Some people from the industry have been involved who make drones. So I think they are involved and they're working for a regulation and policy on the use and application of drones, because at present, since we don't have any regulation, so people are just using them randomly. And then drone technology is actually, in terms of aviation and airworthiness, it is a much simpler technology, because you don't have to comply to very strict safety regulations because they are unmanned. So even when it comes to engines for drones, the regulations or the compliance, uh, human factor safety compliance is more lenient, so it's easier to develop and for the industry to adopt. And then again, in terms of emissions, they have smaller engines, and they fly at lower altitudes, because if you talk about contrails, that's a phenomenon of high altitudes. So they don't give out contrails, and because of the smaller engine, there is, the carbon dioxide emission is also not very high.
Yes. So while listening to your invention and innovation, we are actually curious that how was your innovation received by the aviation industry?
Which one? I have two inventions. One is the supersonic one, and one is the contrail one.
Actually, we're curious to know about both of them. So, like,
Okay. As far as the contrail one is concerned, it has had generally positive feedback. Um, but the industry actually is very divided, because you see, when you talk about research, uh, people just do, they develop solutions, scientists develop solutions, they bring about facts, negative results, positive results, whatever. They present facts, they publish facts, they get their papers, journals, whatever. It does not. But in the industry, there's always like a conflict of interest, because sometimes if developing an environmental technology means that it would compromise some profits for the manufacturer, then it is difficult. The industry is very monopolized, controlled. Um, so there's sometimes there's mixed feedback. Some people dismiss contrails, and also because, as I said, that it's something that is very specific to the aviation industry. So as for carbon dioxide, it's spread over a spectrum of different industries, so nobody can hide it. Everybody knows about it. Nobody can dismiss it. But contrails is just like specific to the aviation industry, and it is not visible. It's hidden up in the sky. So the industry can choose whether they want to bring it up or they don't want to bring it up. Um, but yes, I think generally in public, the response has been very positive. A lot of people now know about contrails. A lot more people know about it than before. And industry, I would say, has a mixed response, but then it does not make a difference as long as your work has a strong backing. If you just float an idea, it's very difficult, easy for somebody to dismiss it. But first of all, because I have a PhD, I've rigored through a PhD on the subject. That PhD is backed by thousands of peer-reviewed journals. There's a scientific consensus by the scientific community that contrails contribute to global warming, their impact. There are different aspects people have researched and worked out. So with those references, it's difficult that anybody can dismiss it. And secondly, that's one of the reasons we are developing the technology by ourselves, because one option that usually one route that people take is they just sell off their invention and patents to big manufacturers, but then there's no guarantee that it would be developed or not, and then depending on the environment. But when you have a working technology, then it's very difficult for people to dismiss it.
So, were you approached by any aircraft manufacturing companies to have your research implement on their aircrafts?
We are in conversation now, but you have to be there is a level of maturity of a technology that you need before you can start approaching people. So we were waiting for that time, and inshallah, as stage by stage, when our technology reaches that maturity, that's when we approach these manufacturers.
Okay. So, Fatma, over to you.
Right, so that was pretty
Okay,
insightful.
Fatma, you have to excuse me for a minute. I need to drink some water.
All right, sure, we'll take
Okay.
a minute's break. Yeah.
Meanwhile, if you like, you can run that product animation. It's 30 seconds.
Yeah. Till Dr. Sarah comes back, we'll just share a video that she had sent over to us.
Yes, I'm back.
Okay, so now we can move on to the second part of the webinar. Dr. Sarah, we would like to talk about your experience in launching a technology-based entrepreneurial venture in Pakistan. So I believe Saad has the first question, that is with regards to where the industry stands right now.
Yeah, I'd like to ask you, what do you think, in your opinion, does the tech industry stand in Pakistan? What is its position currently?
If you talk about the deep tech industry, things are not very good. If there are two things, one is the entrepreneurship side and one is the aerospace industry side. Because well, I'll try to combine both. Number one, when you talk about investment for entrepreneurship, most of the investors are not, they don't have a comfort level with tech intensive products and technologies. And because number one, it requires a lot of infrastructure, a lot of investment into time and into heavy equipment and finances. And then our environment and ecosystem is not very conducive. And secondly, also because investors don't really understand the technology. They want, in terms of entrepreneurship, they want quick returns. They want the company to start generating money within a year, 2 years, 3 years. Aviation has very long timelines. You have planes flying in the air that were designed 20 years ago. You need at least 6, 7 years to develop a product and a technology. And then mostly they have a comfort level with IT industry or with coding and mobile apps, and that's all people understand here, and that's all people invest in, unfortunately. On the other side, when we talk about the industry, we have a lot of resource which is owned by the government and the defense sector. They have big giants like the aeronautical complex, Camera, HIT, HMC, um, different other government. There's some government institutes. They have very sophisticated high-end machinery, manufacturing capabilities, everything, but they are underutilized. They're just huge buildings, infrastructure, machinery, but there's no output. There's no work, and they have no incentive to work or to support commercial industry either. If you approach them for some work, even if you want to, do it on a commercial basis and pay for it, um, it's it's not useful. They are very reluctant, and they don't have any procedures or anything to support the private tech intensive industry or R&D organizations in the country, which is very unfortunate. It's a very wasted resource. I wrote an article that was published in Dawn Business about this in detail, like fault lines in the deep tech entrepreneurship system in Pakistan. Because abroad, what happens, like, these big companies like Airbus, Rolls-Royce, they have a commercial division and they have a strategic division. So the strategic division does all its, what it has to do for the defense side, but the commercial division does a lot of commercial work and development and growth, and so this is how they operate. But we just have we have these resources which are just operating at 30% of their capacity. They are 70% underutilized, and they are just catering for the strategic needs, and the rest of the resources are wasted. And we've tried very hard to get some support, assistance from them, but it hasn't worked out very well, or it hasn't really worked out as it should. If somebody out of their own kindness and own, some people are very motivated, very passionate, they want to help Pakistan grow, and and for that reason they want to support you, they do support you. But that varies from individual to individual. But there is no um, policy on a government level or on an organization level to support the industry, and this is all. It is painful. It is very unfortunate, and it's something that it's not that we don't have, we lack the money or the resource. We just lack the vision. Yeah. So what we do is that we mostly interact with the commercial or the private industry, but then we have to develop a lot of capability on our own as well, which is in a way good that, because you can't get something done from, you can't outsource it, you develop the capability to do it. I mean, there are different machining techniques and whatever the capabilities that are required. So we develop those capabilities ourselves, but then that is expensive for a startup, and that's not the way a startup should be. And it's also very time consuming because that slows down your core prime R&D work. And this is what has been happening.
Exactly. So, keeping in mind that all you've listed above, and also the fact that the patents and the intellectual rights for your Contrailless engine are filed in the UK, what were the propelling factors that still moved you to launch Aero Engine Craft in Pakistan?
I think well, there were various factors, but one, obviously, I'm a Pakistani. I mean, we all have some hopes and dreams for Pakistan, and we want to contribute to our country, and we want to pay back what it has given us. We've had 16 years of schooling here. The country shapes us, makes us, whatever. So you have to pay that back. That's we owe it to our country. And then I thought that it would be great if this invent, because it's a Pakistani invention, if it's launched from Pakistan, and I mean it's something. And also that then there are personal circumstances. Then because this I've worked in the industry here, in the private industry in Pakistan, so there's also this comfort level and the way you understand the system, how the system operates. So all these factors.
Yeah, definitely. A major motivating factor is to give back to the country that has, in a way, been responsible for getting you to where you are. So I believe Saad has a few more questions on what the experience of establishing Aero Engine Craft has been like.
Right. So one of the major concerns of the entrepreneurs that they have is what challenges will they face if they launch a startup in Pakistan? So what has been your experience in launching a technology-based startup in Pakistan?
चैलेंजेस तो मैंने आपको बता दिए हैं. एक जनरल चैलेंज तो ये होता है कि अब आई थिंक SCCP is doing something about it, that the day you are born, you are a private limited company, you are treated like that, you have to comply to tax regulations like that. So now they have made some changes that for the first 5 years they give you some relaxation when you are building up. That's one general challenge. Secondly, when you, as I've I think mentioned that for tech, deep tech, high-end startups, there's no investment. Nobody understands your work. I think यहाँ पे सबसे बड़ा यही है कि nobody understands aviation. It's not like in the UK. Aviation is very common. Everybody they have air shows, they have the industry, people work for it. So you really have to explain the industry and the technology, and then they don't have the comfort level. So there's no investment, there's no funding. If you talk about grants or government fundings, they have a very strange policy. Some grants there were some by Ignite or whatever. You have to be an IT company to get some funding. And other than that, if you are for some HEC grants, you have to be a university faculty. Now, university faculty cannot, as a faculty, you cannot develop this kind of technologies either. So, so that's the second thing. The third thing is that you don't have any access to high-end manufacturing facilities or concerns. I mean, there's limited support in the private sector, and the places where there's a lot of resource, you don't have access to that resource. So you have to either import. Import is again another challenge. You have to pay duties and custom and whatnot to import machinery, and develop your own setup, which is very challenging for a startup. So all the challenges are there.
And I'm sure
So there is no, I mean, it's not very,
not the most conducive
I won't say
environment.
it's very not conducive, yeah, non-conducive environment.
And exactly, I'm sure another major challenge for you must have been finding the kind of workforce you need to propel a startup like this forward. As I remember you mentioning in one of your interviews that you started out with just the two of you and your father. So could you go forward on what it has been like expanding your team and how you hope to take Aero Engine Craft in the next 5 years? Where do you see this going?
Yes, we've had challenges. I've had more challenges with young engineers and graduates uh, from Pakistan, and I think they have very unnecessary expectations. And maybe there are things that I explained in my talk with IMEC-E. Um, so that has been a challenge. One is that they're very restless. They don't want to stick to one job, because you cannot benefit from a company, or a company can benefit from you unless you spend 2 years with them. So they're sitting at one place, applying for another job, going to another job, applying for another job. And I see a lot of CVs like that, like somebody who's worked 3 months here, 3 months here, 3 months, and I reject those CVs, because that means that that person does not have a capacity to learn or to absorb. He's very restless and he would not stay with us. Secondly, I think young engineers, they consider it's like a bonus uh, to say that you are earning this much. I mean, at entry level, it's not I mean, it's not a feather in your cap that you're earning this much, because you could be doing any non-technical work, maybe doing photocopies in a multinational company and earning a lot, but you're not learning. And what rewards you professionally later, and with what is good for your profession and your career growth over the years, is how much you absorb and how much you learn in your early years. So this is so it's been tough in terms of human resource with engineers. With the other staff, Alhamdulillah, it's been okay. But we also train them on the job, but they also stick to their jobs and they learn and grow with us, and we train them as well. And right now we are focusing on one product, which is the contrail-free Aero Engine. Uh, and I think as we grow, once we would also be offshooting into different kinds of engine development for the aviation industry, engines for drones, for small aircraft, and then obviously this contrail-free engine for larger aircraft. So these are our immediate focus areas, and there are some areas in the automotive division as well. But for now, within the next 5 years, this is how we see that, uh, for if we freeze one of the design for one of our engines, for small planes or for the drones, we would set up a production facility for those engines, because it's very difficult to import these engines as well, the large size engines. And then obviously develop this contrail free technology here. As I mentioned, that we would take it to the next level, and develop it on a full scale model, and develop the auxiliary parts for the aircraft, and then take it to testing, and see that ensure that it is commercialized. We hope to commercialize this by 2025. This was like a 7-year plan initially.
Well, we'll all be waiting to see that. Speaking of your projects,
Inshallah.
inshallah, we've recently heard that you have patented a supersonic commercial aircraft engine. So could you walk us through that and tell us, how do you see it impacting commercial air travel?
Okay, now there has been originally there was only one aircraft that was flying supersonic in the commercial domain. That was the Concorde, if you've heard of the Concorde. And then it flew for some time, and then it was grounded. And well, there were different reasons for it to be grounded. There were maybe financial reasons, political reasons. But when one of the technical reasons it was grounded was that it was very noisy, because when it created a sonic boom, and even taking off over airports, it would create a lot of noise. So such aircraft are only allowed to fly supersonic over sea, or where they would not create a sonic boom over the land. But even with that, it was still noisy for basically takeoff and landing. And it could not comply to airport noise regulations because airports are close to human settlements. So this new engine that we have developed is basically on that concept that it is an engine that is low noise. It takes off quietly, it lands quietly, and then when it's high in the atmosphere, it can fly and takes off subsonic, and in high altitudes, it can fly supersonic. So I filed this last year in June, and we were granted within 8-9 months. And now we don't want to develop this technology by ourselves. We just want to sell this patent to one of the manufacturers because it's very high-end technology, and then use that to fund our contrail-free aero engine. And now there's a revival in this aerospace supersonic commercial flying. There are companies which are building supersonic planes for executive jets, for long haul flights. And they're all relying on the Concorde because Rolls-Royce basically because they developed the Olympus engine for the Concorde. But then that engine had its problems. So this is something that the industry can develop, and they have a quieter supersonic plane, and it is a solution to commercial supersonic flying.
That's great to hear. So Dr. Sarah has been really kind to share her time and valuable experience with us. So we're going to take 10 minutes for an audience Q&A. If anyone has any questions, they can raise their hand and we'll be unmuting you so you can put your question forward directly.
अस्सलाम
वालेकुम सलाम।
मेरा नाम हरून है, मैं दरअसल EME से हूँ, तो आप एलुमने हैं हमारी। तो मेरा अभी एंड में से जो है आपके जो लेक्चर हुआ है उसके एंड से मेरा एक सवाल है कि आप ये सुपरसोनिक वाला पेटेंट क्यों बेचने बजाय इसके अगर आप कंट्रोल फ्री इंजन का अगर आप पेटेंट बेच लें, क्योंकि सुपरसोनिक जेट इंजन के जो आगे कस्टमर्स आएंगे वो तो खासे ज़्यादा होंगे, क्योंकि अभी तो एनवायरनमेंट इशू है, लेकिन कोई इसको कंसिडर ज़्यादा नहीं कर रहा। अभी भी लोग जो है बिजनेस साइड को ज़्यादा प्रेफर करते हैं। और इस वजह से
नहीं, उस दो वजह, एक तो यह है कि जो ये सुपरसोनिक तो एक कमर्शियल टेक्नोलॉजी है, इसको कोई भी बना लेगा, कोई जो इंटरेस्टेड पार्टीज होंगी वो खरीदेंगी, वो बना लेंगी। लेकिन जो एनवायरनमेंट टेक्नोलॉजीज है ना, वो फिर इंडस्ट्री बनाती नहीं है, बिकॉज उसमें फिर उनका कुछ कॉन्फ्लिक्ट आ जाता है इंटरेस्ट का, या थोड़ी सी उनको एक पेनल्टी होती है। तो उसके लिए ज़रूरी है कि वो चीज़ इंडिपेंडेंटली डेवलप की जाए और फिर उनको दी जाए, ताकि वो एक वर्किंग टेक्नोलॉजी को डिसमिस करना आसान नहीं होता। और फिर ये कि अगर आपने इन्वायरमेंट, जैसे ऑटोमोटिव इंडस्ट्री में रेगुलेशन है ऑन एमिशंस, एविएशन इंडस्ट्री पे भी होनी चाहिए, लेकिन वो तभी हो सकती है व्हेन यू ऑफर देम एन अल्टरनेट सॉल्यूशन, because if you tell them contrails are very bad and they should be banned, so they cannot ban flying. So if we say that okay, you have to ban contrails, but there's an alternate technology available, then they will be able to pass a regulation or whatever. So that is why it is important to develop the contrail technology. And the other one, as I said, that it's very difficult, we can't get funding here. Nobody will fund this further. So we need funds to develop it to completion. So that's why we have to sell this patent. And thirdly, it's even more complex to develop that engine than the contrail-free air engine, because it involves shock waves and crossing the sound barrier and supersonic technology. So for now, I think this is the best way. We can only focus on one, and I think the environment one is more critical for the world, and that's what we should be focusing on at the moment. And this one, somebody, whoever needs it, will make it. But one of the options is usually that if you sell it, you don't give exclusive rights. You keep your rights as well, that you can make it, they can make it. So we don't know, maybe in the future.
अगर हम इस तरह से सोचें कि अगर कंट्रोल फ्री इंजन वाली अगर टेक्नोलॉजी ज़्यादा सोफिस्टिकेटेड हो जाती है, अगर तो कोई एरोस्पेस कंपनी जैसे स्पेस एक्स होगी, वो जैसे इलॉन मस्क जो खासा इंटरेस्टेड नजर आता है इसके अंदर, एनवायरमेंट इश्यूज के अंदर, ऐसी कंपनी को अगर
जी
सोफिस्टिकेटेड बेच के थोड़े छोटे लेवल पे जो
yes, you can sell, but you have to, you see, um, usually you have to bring it to a maturity level to sell as well. You can't just randomly, because it's like you have a pattern, it's somebody's creation idea. There's so much technology that goes into it. So it's best that you develop it and you sell it. I don't know, Elon Musk maybe has a lot of his own ideas. I'm not sure he would be interested. For the supersonic, I know that there's Boom Supersonic, Aerion Supersonic. They're all even this some Virgin Galactic as well. There are 4 or 5 people who are all trying to make these supersonic travel vehicles. So one of them can develop this.
और मैम लास्ट क्वेश्चन के कोई इंटर्नशिप का स्कोप जो आपकी कंपनी में वो कब से नहीं स्टार्ट होगा?
Internship, we don't offer internships because you see, we are a small company. Big companies can absorb internees. Small companies have a lot of work. They can't spare time, and they don't have the time span to wait for people. They have limited resource. They don't have a time span to wait for people to learn first and then start delivering. So we don't offer internships. We might offer, I was thinking about this, that we might offer like a paid training program in which you pay us and you learn from us, but and we don't have any internship opportunities.
Hello, ma'am.
As
Hello, ma'am. This is Mohammed Arsha from EME, BS Mechanical Gaming student. Ma'am, actually, my question was that when you were given a research topic in Greenfield University about trails, uh, as you mentioned earlier, and it's obvious that many attempted, but they were failed. But what kept you motivated and go for it? And secondly, my question was that I go through your profile on LinkedIn, so it was so much awesome and it's so much attractive. So my question was actually that what type of skills we should develop during our BS period, and what courses, extra courses to help us, or internship will help us. So what should be our activities so we can increase our skill?
Okay. Okay. First of all, what I mentioned was that there were many methods in research domain. A lot of people do different types of research, and some lab experiments on different ideas. It's not that they failed. It's just that when you have to there is a long route from research to product commercialization. Everybody does not want to take that route. Some people take the academic route, they do further research, go into further depth and detail. But then, we chose that for our product, we would take the commercialization route. We would develop this research into a product which can be sold in the global market. So that is what I meant. But in the research domains, they are like, for the literature review that I did, there were 7, 8 different methods. Some of them were for environment, some were not for the environment, but people did research on them, but they didn't take it any further. Okay, skills that you need to develop. Yes, I think, as I mentioned earlier, that for an early career stage, you should focus on learning, because it's not a feather in your cap that I'm earning this much and I'm earning this much. You have to, it's good to have a diversified experience. You have to be, wherever you go, try to stay with that organization. for 2 years at least, for you to benefit from them and them to benefit from you. And try to learn as much as possible. You should have a very steep learning curve, right? And utilize your time if you are given a chance to for internships in big organizations, whatever, wherever. Even if they don't pay you for internships, you must take it as an opportunity, because even an unpaid internship is just like the way you go to a university, you pay a university to learn. So even if you are, you're going to an industry, even if you have to pay them to learn, that is fine. But at least if you are getting some, professional benefit out of that place, it is important. And yeah, basically that. And when you are writing your CVs, like I see a lot of CVs that, as I said, that you should not be jumping from one job to another. And secondly, some students they write like a list of 10 projects, right? And they claim that they have worked on this and this and this and this and that. And then when you go for the interview, whatever you write on your CV, you will be questioned about it. And the other person, because what is in an interview is just an evaluation of, what you claim, whether we're just verifying that what you claim is it true or false, whatever it is, your home address, your location, whatever. Somebody will go and verify that. If you claim that I've done this project, they will ask you questions from that project. So it's best, even if you just write one project, something that you know properly, it's your final year project, and write it in detail, and then people will ask you questions from that. That is how at least we evaluate. If you have done like different semester projects, so you should also write your level of involvement. Okay, for this project, I was just a report writer, or I was just the purchaser of components, or whatever you order. I just did the design, my friend did the design, I just made the drawings, whatever. But you write, don't overclaim, because employers they're smart people. Okay, and if they are from your own area, then they are able to figure out that this is misrepresentation of information. So that's a very negative impression. Okay, so it's best to write one project and write it in good detail, or for smaller projects, just mention your level of involvement.
Right. Thank you, Dr. Sarah. We would like to wrap up this session. It was a fairly long and very informative session with you. I know you gave a couple of advices to us already, but if you would like to give one piece of advice, what would it be?
Okay, I think it's important to value time. Time has a worth. Make good use of your time, and in early career stage, don't look for financially rewarding jobs. Look for professionally rewarding jobs, because they ensure growth in the future. If you're not learning at an early stage of your career, just after money, then your growth will achieve a plateau very soon. But if you focus on that, and I'm sure, because as young engineers and within our culture, we can afford that. We have plenty of family support, and there is time before you start your own family. So make that a priority. Okay.
Right. That was a great advice. Thank you. I would like Abdul Ahad to please end this session.
All right. So as we are approaching to the end, ma'am, it was an absolute pleasure to have you here. Thank you for sharing your incredible insights. And mashallah, your achievements are tremendous. And also thank you all the viewers for joining us and taking out time for this webinar. Stay tuned for our next webinar coming this Saturday. We will be announcing our guest speaker soon. Until then, stay safe and have a good weekend. And it's an Allah Hafiz from us.
Allah Hafiz. Bahut shukriya. Jazakallah.
Allah Hafiz. Thank you once again.